Hello. Today I will be talking with you about mercury dynamics within Castaic Lake State Recreation Area. My name is Greg Jesmok, my advisor is Dr. Priya Ganguly, and I'm a graduate student at California State University in Northridge. Here, we are looking at the highly vegetated, moderately sloped hillsides that drain into the northeastern arm of Castaic Lake, a reservoir approximately 65 kilometers northwest of downtown LA, on the former land of the Piabitom, now part of the Fernandino Tataviam Band of Mission Indians. With a volume of approximately 0.4 cubic kilometers, it is the largest reservoir in LA County and the third largest storage facility associated with the California State Water Project, which is shown on the figure to the right in light blue, extending almost the entire length of California. In addition, Castaic Lake is regularly utilized by the surrounding community for fishing and recreation, and also features a pumped storage hydroelectric power plant that provides power to the residents of Los Angeles daily. However, Castaic Lake is also one of 71 California reservoirs listed as impaired due to elevated mercury concentrations in fish, prompting the California Environmental Protection Agency to issue a fish consumption advisory for certain species that exist within the lake. These fish contain a bioaccumulative neurotoxin known as monomethylmercury that in humans can lead to persistent motor deficits, adverse cardiovascular effects such as heart attacks, and impairment of speech, amongst other maladies. So what is the situation at Castaic? On the left, we see a Google Earth image of Castaic Lake and its surroundings, with a KMZ overlay of total mercury deposition acquired from the National Atmospheric Deposition Program. This figure shows low levels of mercury ranging from between 0.01 to 0.05 milligrams per kilogram exist in shallow soils, with complementary maps from NADB showing reduced total mercury levels at depth. Where is this mercury coming from? As many of us know, mercury is quite labile and transfers easily between Earth's reservoirs. It exists as multiple species. Amongst those are elemental mercury, known as Hg0, and two others that we'll be focusing on in this study, inorganic mercury and monomethylmercury. Inorganic mercury is primarily released in the atmosphere by humans via mining operations and fossil fuel combustion, whereas monomethylmercury is formed by anaerobic bacteria that convert inorganic mercury to monomethylmercury through the addition of a methyl group. We can see one such mercury pathway in the figure to the right from Engstrom 2007. Elemental mercury is oxidized in the atmosphere to inorganic mercury, which is then deposited via precipitation and or dry deposition onto land, vegetation, and in our waterways. It is then methylated by anaerobic bacteria in zones of hypoxia such as swamps, the water column, and profundal sediments, where it becomes bioavailable. Monomethylmercury then moves up the food chain, bioaccumulating and biomagnifying within fish, as we see occur in Castaic Lake. But why should you care about mercury? Well, there are increasing levels of mercury entering our atmosphere each year. Our warming climate induces wildfires, which liberates mercury via burning of biomass and charring of sediments. In addition, humans are burning fossil fuels such as coal, which naturally contains mercury, at unprecedented levels, propelling temperatures even higher. How does all of this relate to our project at Castaic? In accordance with Butel et al. 2014, we anticipate higher concentrations of monomethylmercury will be found in anoxic bottom waters at Castaic Lake. To assess this, we are seasonally collecting filtered and unfiltered total mercury and monomethylmercury water samples from tributaries and the lake perimeter, along with creating a water column depth profile using a Niskin GoFlow water sampler as pictured on the right, to determine where and when stratification occurs within the lake that would lead to potential zones of hypoxia and monomethylmercury accumulation. We're collecting sediment samples from these same localities with profundal sediments gathered using an Ekman dredge. Ancillary parameters such as temperature, pH, conductivity, dissolved oxygen, and turbidity are measured using a YSI multi-parameter water probe, while an OTT MF Pro flow meter is used to measure stream discharge for a more holistic understanding of lake processes. Additional analytes being collected are suspended particulate matter, polycyclic aromatic hydrocarbons, trace metals, nutrients, and dissolved organic carbon. So where are we with our sampling? Well, preliminary data indicates elevated total mercury and SPM signals within the tributaries leading into Castaic Lake, demarcated along with lake perimeter samples by turquoise pins. In addition, we have thus far found reduced total mercury and SPM signals within the water column, the site location shown here with a pink pin. These elevated total mercury concentrations are up to greater than 3 nanograms per liter for filtered samples within the tributaries, while unfiltered samples show values rising to almost 9 nanograms per liter. Alternatively, water column profile samples feature total mercury values near the detection limit, topping out around 0.2 to 0.3 nanograms per liter for filtered and unfiltered samples, respectively. Monomethyl mercury analyses are in progress, with acidified samples safely stored in our lab refrigerator. And finally, SPM values vary considerably within the tributaries, ranging between 31.7 milligrams per liter for Naylor Place to greater than 580 milligrams per liter along Lake Elizabeth Canyon Creek following a storm event. Meanwhile, water column SPM samples range from 0.4 to 1 milligram per liter, with rising values moving towards the surface of the lake. Where does this leave us? Well, future work will focus on the northeastern arm of Castaic Lake, which features ease of accessibility, multiple fisheries near the tributary inlet, and the aforementioned elevated total mercury values. We aim to complete a water column depth profile in the southern portion of the northeastern arm and to procure profundal sediments moving from the greatest depth to the shallows to isolate the depth where hypoxia occurs. And with that, I would like to thank the numerous individuals and agencies that helped push this project along. Thank you.